Have you ever seen a real live dinosaur or dragon? You haven't, because scientists have determined that dinosaurs lived millions of years ago. And you know that dragons only flared their nostrils and breathed fire in fairy tales. But that doesn't stop animators from trying to bring both creatures to life on film. Using computer animation and motion geometry, artists take dinosaurs and dragons from science and fiction to the screen.
Go behind the scenes to see how the biggest special in Animal Planet history was created.
They transform geometric shapes using translations, or slides, moving a shape from one location to another without changing its orientation, size, or shape. Rotations, or turns, making the figure rotate about a single point or axis along a circle. And reflections, or flips, reflecting one shape to the other side to produce its mirror image. These transformations help artists build the creatures on screen with depth and the sense of motion, making the animals and their worlds look real.
We set out to make dragons as convincing as possible.
Let's have a look.
So let's talk about a translation. That's a slide that moves every point of a figure in the same distance in the same direction. Look at this simple picture of a translation. Here's triangle ABC, here's triangle A prime, B prime, C prime. All that happened is it slid to the right and then it slid down. Each point slid in the exact same way. Point B also slid to the right and then slid down. Every point is made by a slide. Here's an example of how we would do this in the coordinate plane. The vertices of triangle ABC are A, 1, 1, B, 3, 4, and C, 5, 0. Graph the pre-image and the image by translating left 3 units and up 2 units. Write the coordinates of triangle A prime, B prime, C prime. So let's begin by graphing triangle ABC. A is at 1, 1, B is at 3, 4, and C is at 5, 0. And we'll connect the points so we see that triangle. Now we're going to slide left 3 and up 2 to translate. So each point will do the same thing. Left 3 units. So from point A, we go 1, 2, 3 to the left, and up 2 units. 1, 2, up. That's where point A prime will be, the image of A. Let's do the same thing with points B and C. From B, 1, 2, 3 to the left, up 2. There's point B prime. C, 1, 2, 3 to the left, 1, 2, up. And there's point C prime. Now we'll connect. And you can see how this was just a slide, like that dinosaur's footprint. Sometimes we perform 2 transformations. Example, triangle FMA is reflected about the y-axis. That means the y-axis is the line of reflection or the mirror line. Then it's translated up 9 units. What are the coordinates of point M after the transformation? So let's do those 2 transformations. First, the reflection about the y-axis. So that means the y-axis, that's our line of reflection. So I'm going to draw along the y-axis and label that this is the mirror line or the line of reflection, the y-axis. So let's look at where each of these points are, A, F, and M. Now, we don't actually have to reflect the entire triangle because Notice this problem is only asking about point M. Let's focus then just on point M. Here's point M of our triangle. Focusing on that, where is it located in relation to the line of reflection? From point M, I'm going to count directly to the line of reflection. 1, 2, 3, 4, 5, 6. So notice that was 6 that I had to go in this direction away from the line. So I'm going to go in the exact opposite direction. Point M is 6 units to the right, so I'm going to go in the other direction 6 units to the left. So I'm going to count 6 units to the left. 1, 2, 3, 4, 5, 6. And that's where point M prime is first located. But remember, we have 2 transformations. So let's look for the other one. Now we're going to do the translation up 9 units. So from where we stopped, where I did my reflection of 6 in one direction, so 6 in the opposite direction, now we'll do the translation up 9 units. So from where I stopped, 1, 2, 3, 4, 5, 6, 7, 8, 9. So I went up 9 units, and that's where I land, and M prime is there. So I used the graph to help do it. But notice it says, what are the coordinates of point M? So to find that, I have to count from the origin. Here's the origin, so let's count in the X direction first. 1, 2, 3, 4, 5, 6 to the left, so M prime, -6, and then 1, 2, 3, 4, 5, 6, 7 up. And there I have it. M prime is at -6, 7. Can you think of other places where you've seen transformations? Take a moment to describe examples outside of the classroom that demonstrate symmetry, reflection, rotation, and transformation. You may give one example per term or an example that combines them. Oops, I mean translation. So think about outside the classroom, symmetry, reflection, rotation, and translation. What have you seen?